Alrighty, guys. Let's get started. So we're gonna for this problem, all you have to do is draw the Lewis structure. So this is the easy one where you only draw the valence or the outside electron. So let's go to the periodic table and just draw all these. Okay, so FHCbr. Okay, that's more for me to remember. FHCbr. Okay, so let's start with F. Okay, how many valence electrons does F have? 7. Yeah, it's 1, 2, 3, 4, 5, 6, 7. So F is really easy to draw. You just need to put 7 valence electron around it. That's it. HCbr. Okay, let's go on to H now. Now H is the first box in its row, so it's just gonna have 1 valence electron. Okay, we'll move on to carbon. Carbon is right here, and carbon is number 4, so it's gonna have 4 valence electrons. And then Br is right over here, so we're gonna go 1, 2, and then this is the same example we did last time. We're gonna skip groups 3 through 12, and then go to 3, 4, 5, 6, and 7. So Br is going to have 7 valence electrons. Okay. Alrighty, so that's how you do a Lewis structure. So hopefully you guys are comfortable with that, because you will need to know that for today. But do you guys have any questions about any of those? Yes. No, as long as you have them, I'd say in the cardinal directions, up, down, left, right. If like, let's say for, I don't know, for like F right here, you got 2 on this side and you only got 1 on this side. That's totally fine, as long as you got the correct number. Okay, good question. Any other questions? Okay, let's move on to the new stuff. So up until this point, so yesterday and right now, we just went over how to draw these elements when they're by themselves. But like I told you guys, for the final, we're going to be researching bigger molecules. And so today we're going to be putting them together to make small molecules, and then we'll move on to the bigger and the bigger ones, okay? Okay, so you guys don't need to write this part down, but basically the reason why molecules form is because atoms want to have complete outside or valence shells. Okay, and they do that by forming covalent bonds, and you guys want to write this part down. And so what they do is they form covalent bonds, and they do that by sharing electrons. So different elements will share electrons with one another. So we're going to be learning how to draw that today, covalent bonds. Just make sure you guys jot that down, just so you know what kind of bonds we're talking about. And then we're going to jump straight into the first example. Okay, so we're going to basically learn how to draw these covalent bonds. We'll start with Cl2, which is a chlorine gas. So let's take a look at chlorine on the periodic table. Okay, so if we take a look at chlorine, we're going to count the valence electrons to get to chlorine. It's going to be 1, 2, 3, 4, 5, 6, 7. Okay, so if we drew a Lewis structure of chlorine, it will have 7 valence electrons. Okay, so far so good? All right, now Cl2 is made out of 2 separate chlorine atoms, so we're going to have 2 chlorines. Okay, so I'm going to draw another one right next to it. I'll do it a different color just so it's a little bit easier for you guys to distinguish. Okay, but chlorine gas is going to be made out of 2 chlorines, and both of them have 7 valence electrons. Okay. Now, they don't have complete valence shells because if you guys remember, the second row has 8 boxes, right? And that means that it can hold 8 valence electrons. So these only have 7, so they're not complete. So they're going to try to have 8, and they're going to do that by sharing electrons. Basically, what's going to happen is these 2 atoms are going to get really, really close together, and they're going to get so close to the point that it's going to look like they are sharing electrons. So they're going to get super duper close. And if you look at it this way, if these electrons are really, really close to each other, if I just look at this part right here, it's almost like it has 8 valence electrons. And if I look at only this part right here, it looks like this guy only has 8 valence electrons. So that's how covalent bonds are formed. But this is a little bit annoying to draw. So whenever you have shared electrons like this, what we do instead is we just draw a line to represent that there's 2 electrons. So this is going to be your structure. Okay, this is what Cl2 is going to look like. This part right here. What's up, Mr. Pepic?
Hello, Mr. Joe.
How do you forget my name? It's one letter. Okay. It's 2 shared electrons. Guys, have you guys watched Breaking Bad before? Doesn't he look like Walter White? He does, right? Yeah. Okay, so that line represents 2 shared electrons. Okay. So that's what the structure of Cl2 looks like. Okay, and so basically that's what we're going to be doing today. We're going to be drawing these different molecules. We're going to put the elements together. Now, there's an easier way to draw the structure, and that's what I'm going to go over with you guys right now, okay? Okay, but conceptually, does this make sense, how this works? Basically, they share electrons, and then it looks like they have 8, okay? Alrighty, let's move on to some other practice problems. But before we do, I'm gonna give you some of the rules that you guys can use to not rules, but tips that'll help you guys out. Okay. Actually, I guess it is a rule. So the title of the lecture is Octet Rule, and you guys want to write this part down. But the Octet Rule is basically the kind of guiding rule that you'll use to draw all these structures. Basically, when you draw these structures, all the atoms will want to have 8 electrons. Okay, so when in doubt, just you got to work out the molecule so that every atom has 8 electrons. Okay. And again, when you copy this down, you don't need to do it word for word. You can paraphrase it however you like. But the octet rule is the tendency for atoms to want 8 valence electrons. All right, now there's going to be 2 notable exceptions that you'll need to know for this class. There are more, but we're only going to stick with these 2 exceptions. The first exception is hydrogen, or H, and H can only have 2 electrons. Okay? And you're going to be seeing H a lot, so make sure you guys keep that in mind. H can only have 2 electrons. Okay. Okay, another way you could think of that is it can only have 2 electrons, or it can only have 1 line connecting it. Okay, it can only have 1 line connecting it with different atoms. Okay, and the second one, you won't see this too much, but it might pop up depending on what molecule you decide to research for your project. But boron, it could have 6 or 8. Okay, so those are the 2 notable exceptions. And there are more, but we'll leave it just there for now. Okay. All right, and a couple last things when you guys are making the structure of the molecule. So we only looked at binary molecules, so there's only 2 atoms, but today you'll be seeing some that are a bit bigger. And so when you're organizing the structure, just keep in mind H always goes on the outside of the molecule. Reason why is it can only make 1 connection. So if it's in the middle, you got to make multiple connections, right? So H always goes in the middle because it can only make 1 connection. And then if you ever see C and Si, they like to go in the middle as well, or they like to go in the middle. Okay, so H always goes on the outside, and C and Si always go in the middle. Okay, and so those are the 2 tips that I'll give you. That'll help you guys draw the vast majority of the molecules we'll be looking at. Yeah, that's it. And then we're just gonna do a couple practice, and I'll get you guys started on your assignment. Alrighty, guys. So let's move on to the first practice problem. We'll start with the easy one, and then we'll progressively get into the bigger molecules. But let's start with HBr. Okay, so we're gonna first, let's just start by drawing the structure of HBr. Oops. Okay, and so what we're gonna do is we're just going to first start by counting all the valence electrons. So let's look at the periodic table and count up these atoms' valence electrons. So if you look at hydrogen on the periodic table, how many valence electrons does hydrogen have? 1. Yeah, and then how many does Br have? 7. Good. Okay, so the first thing you want to do whenever you're drawing these structures is you want to count the valence electrons. Okay, so hydrogen has 1 valence electron. Bromine has 7 valence electrons. So if we add them up together, we have 8 valence electrons that we're going to be working with. So in this structure, in this picture that you're going to draw, you can only have 8 electrons. Okay, you can only draw 8 electrons. And that's how you'll connect all the elements. All right, so what we're going to do now is we're just going to kind of structure the molecule. There's only 2 of them, so we can just kind of put them right next to each other, right? H and Br. I'll put them a little closer. Okay, so first thing you want to do is you want to count the valence electrons, which we did, and then you want to kind of organize them together based on the rules that we saw earlier. There's only 2 here, so we can just leave it like that. All right, next thing we want to do is we want to connect the atoms because they're one molecule, right? So they got to be connected. So we're just going to draw one line for now to connect these 2 together. Okay. Now, if you draw one line, how many electrons does that line represent? 2. So if we use 2 of them to connect them, we only have 6 left over, right? That we can still work with. All right, now that these 2 are connected, all we got to do is make sure everybody has 8 and hydrogen has 2. So if we take a look at hydrogen right here, hydrogen has a line next to it. So that means hydrogen has 2 valence electrons. But bromine right here needs to get to 8. So what we're going to do is we're going to add electrons to bromine until it gets to 8. So it has 2 because of the line, 3, 4, 5, 6, 7, 8. And so we added 6. So we used them all up. And there you go. That's the structure of HBr. Okay. So basically what you're trying to do is to make sure everybody has 8, hydrogen has 2, and then you're going to be using these lines to connect them. Okay, and the line represents 2 electrons. Yeah. Yeah, but all the molecules that you're gonna look at, they're gonna work out. Because if it can't form 8 like this, that molecule, that chemical basically can't exist. Yeah. Alrighty, you guys ready to try maybe a little bit harder one? Yes? Okay, let's try it out. Okay, so I'm gonna give you guys about 3 minutes to try H2O. It's the exact same thing that we just did. We're gonna be looking at the structure of water. Okay, and I want you guys to try to draw the structure. Again, make sure you start by counting the electrons, then organize them based on the rules that we saw earlier, and then just make sure, at least in this case, oxygen has 8 and hydrogen has 2. So I'll give you guys about 3 minutes to try that, and then we'll see if you guys get it. We got a couple more examples to do. Okay, so if we take a look at H2O, we're going to start by counting the valence electrons. So we take a look at hydrogen. Every hydrogen is 1, right? So there's 2 hydrogens, so 1 plus 1. And then oxygen is 6. So we're going to be working with 8 valence electrons. Okay. Any questions on that part? Okay. All right. Next thing we're going to do is we're going to organize the atoms so they're in like a specific structure. Now, we said hydrogen always goes on the outside, right? So that means hydrogen's going to have to be, you know, on the extreme ends of the molecule. And that means obviously O is in the middle, right? Because if there's an outside, there has to be a center. Now, if you organize it like this, if you put H on top, O like this, that's totally fine as well. This structure works. If you wanted to do it like this, That's totally fine too, as long as the H's are on the outside and the O is somewhere in the middle between them. Okay. All right. Next thing we're going to do is we're going to connect all the atoms together. So we got to connect H with oxygen and oxygen with H. Again, you need to connect all of them because they're part of the same structure. Now, each line is 2 electrons. So we used 2, 4. So 8 minus 4 is going to be 4. And so we still have 4 electrons that we need to draw on this molecule. Okay. Okay, so if we take a look at H, is H happy? Is it completely full in the valence shell? Yes, because it has 1 line, it's 2 electrons. This one's also happy because it has 1 line. But if you look at oxygen, how many electrons does it have right now? Yeah, it only has 4 valence electrons. So it needs to get to 8. So we need to add 4 more. Luckily, we only have 4 more to work with. So we'll put 1, 2, 3, 4. And then that's going to make oxygen happy. And there you go. That's going to be the structure of H2O or water. Okay. And again, if you oriented the molecule differently, that's totally fine. If you got this, that's fine as well. If you got this, that's also fine. Okay. As long as both hydrogens are connected to the oxygen and oxygen has these 4 dots around, or these 4 dots around it. Okay, so one thing I forgot to mention in the previous problem is the second question. How many shared and lone pair electrons are there? And you'll have to identify this as well. But basically, shared electrons are how many electrons form lines, okay? So yeah, there's 2 lines, and each line is 2 electrons. So there are 4 shared electrons, okay? Since there are 2 lines, you got to double it for the electrons. And then the lone pair electrons are basically how many electrons are just kind of dots. So basically, how many dots do you see in the molecule? There's 4 dots. So there are 4, lone pair electrons. Okay, so that's this part right here. Okay. Okay, so just keep in mind, shared lines are just, or shared electrons are how many lines are there. And then lone pair electrons are how many dots are there. Okay. Okay, so we have 2 more problems that we're going to finish up today. So I'll get you guys started on the next one, okay? But do you guys have any questions before we move on? Easy peasy? Alrighty. So let's go on to the next one, CH4. So I'll give you guys about 4 minutes. You can work on this with the person next to you. See if you guys can get the structure for CH4. Okay, guys, so let's go to CH4. I'll count the valence electrons for you. Hopefully you got 4 for carbon and then 4 total for hydrogen because there are 4 of them, 1 each. So you got 8 valence electrons, same thing as before that you're working with, okay? Okay, next thing we're going to do is we're going to organize the atoms together. Now, if you guys remember, carbon always goes in the middle, right? That's one of the rules that we talked about. Carbon is always going to go in the middle, and then hydrogen always goes on the outside. Now, before we structure this together, one thing I do want to mention is that carbon is always on the outside, and the reason why is because it can only make 1 connection. Every carbon can only make 1 connection with another atom. Okay, so a common mistake that I see, that I've seen throughout the years, is a lot of people do something like this, okay, because lines are kind of easy to visualize. Now, the reason this doesn't work is because all the atoms need to be connected, right? Now, this hydrogen right here, if we organize it like this, it has to make 2 connections, right? And then that means hydrogen is going to have 4 valence electrons. So this is the reason it doesn't work. It's because hydrogen can only make 1 connection. And so we need to organize it in a way where each hydrogen can only make 1 connection. Okay, so just keep that in mind. I know that lines are kind of easy to think about and where we naturally tend to go to when we structure it like this. But they can only make one connection, so this does not work, okay? So, based on the other rule that we talked about, carbon going in the middle, carbon has to be in between, basically trapped or surrounded by all the hydrogen. So it's gonna look something like this, okay? Okay, now we need to make sure everybody is connected because it's one structure, right? It's one molecule. So we're gonna connect the hydrogen with the carbon, so on and so forth. And if you look at all the hydrogens, they all have one line. So they all have 2 electrons, so they're happy. And then if you look at carbon, there's 1, 2, 3, 4 lines, which means it has 8 valence electrons. So this is gonna be the structure of CH4. Okay, and there's gonna be 8 shared electrons because there are 4 lines. And then there are 0 lone pair electrons. Okay. And again, if you oriented this a little bit differently, so if your structure makes like an X shape, that's totally fine. It's the same thing. You just need to tilt your head and you'll have the same structure. Yeah. Yeah, whatever you have enough electrons for. Yeah. You won't see boron very often though. Alrighty, any questions about this? Yes.
Why didn't we like get any electrons?
The dots, the lone pairs. Yeah, it doesn't have any because we don't have enough electrons to do that. Because we only had 8 to work with, right? All the hydrogens need to connect to carbon. And once you made all the connections, you used up all your electrons.
Is that only 4?
It's 4 lines, but remember each line is 8. So, or sorry, each line is 2. So it's, you got to double it. So it's going to be 8. Good question. Yeah.
Situation where
No, if they're in the same formula, it's one structure, so they all need to be connected. Yeah. Alrighty, let's do the last one and then we'll be all done. Okay, now this one I'm gonna do with you. So sometimes you're gonna see structures that look like this. Okay, I want you guys to write this formula down. Because this is where it starts looking really freaky, right? The structure is getting longer. There's more elements to work with. Okay, but these are actually super duper easy. I'd say even easier. Yes, slave. Okay, so sometimes you'll see structures where if you guys look at the formula, the elements are separated, right? Like all the carbons aren't put together. It's not C3, it's the C's are all separated and the H's are all separated as well. So when you guys see a formula like this, basically what this means is whoever wrote the formula is trying to tell you what the molecule looks like. Okay, so let's start by just counting all the valence electrons. Let's do this first step. So carbon we know is 4. Okay, each hydrogen is 1, so there's going to be 3 here. There's going to be 4 here, 2 here, 4, and then 3. So if we add them all up, we will get, I think, 20. Okay, 20 valence electrons, right? 7, 14, and then 6, okay. So this structure is going to have 20 valence electrons. All right, next thing we got to do is kind of organize the atoms together so that they are in like a structure. Now, like I said earlier, when the formula is written like this, where the elements are separated from one another, it's telling you what the structure kind of looks like. So if you guys notice right here, there's a C and then H3, right? Okay, what that means is there's going to be on the left side a carbon, and there's going to be 3 hydrogens connected to it. Okay, so it's the hydrogens are going to be around that carbon. Okay, that's basically what the structure is telling us. Okay, and if you look right here, there's CH2, which means right next to it, there's going to be another carbon, and there's going to be 2 hydrogens connected to that carbon. Right, this is a lot easier, right? Especially when the structure is given to you like this. And then on the right side, there's going to be 1 more C, and then there's going to be 3 hydrogens around that carbon. So you can already kind of see what this molecule is going to look like just by looking at this formula. Okay. And so from there, we can just count the electrons as we make the connection. Okay, we're gonna make a connection here. That's 2 electrons. 4, 6, 8, 10, 12, 14, 16, 18, 20. And that's all 20 electrons. And there you go. That's your structure. Okay. It's really big, so it looks kind of intimidating, but that's pretty much it. It's actually a lot easier when it's separated out like this, because then you can just put them in order based on what the formula looks like. Okay. And you'll have a couple that looks like this on your assignments today. Alrighty, guys. So that's it for the examples. I will give you the rest of the class period to work on your assignment. Yeah, let me know if you have any questions or if you guys want to check the answer key.